So we've got our little mini lecture on lesson 5 here. This is research design or experimental design. I'm going to talk about most of what's in the lesson and then get that value-added education going. We'll talk about some other things that are important too, relative to experimental design. So a single subject research design, SSRD, single subject research design. This is an entire experiment conducted with one subject, though it can be replicated across other behaviors or subjects. There's someone at the door there, please. Okay? So we can do an entire experiment with one subject, and we can also then replicate it with more behaviors or more participants. Single subject research designs, in general, are used to demonstrate what causes behavior to change. That's an experiment. When we do experiments, we are determining or trying to determine the cause of a change in behavior. Research is a broader title, but experiments are a specific type of research. Some important terms here. Replicate. That's in the definition. Replicate is to reproduce or to duplicate. So in our definition of a single subject research design, we can replicate the research using other behaviors or additional participants. We're going to use the same procedures and study the effect on another behavior or on another person or individuals. We're going to replicate, duplicate. Variable. A variable is a phenomenon, something that we can observe, measure, and possibly manipulate. This is a variable. In science, they talk about variables. Phenomena that can be observed, measured, and potentially manipulated. We've got a couple examples here. Height is a variable. Can we measure the height of anything? Sure. Okay? Weight is another variable. Can we measure weight? Absolutely. Okay? Now, nasty talk. We could come up with a behavioral definition of nasty talk. Could we measure it? Sure we can. We covered that lesson already. We can measure nasty talk. We can count it. That's event recording, right? Count the number of times it occurs. We can do interval observations, have a series of consecutive intervals, and record plus if the nasty talk occurs in that 10-second interval, minus if it doesn't occur in that 10-second interval. We can do momentary time sampling. We do a 10-second observation after 20 minutes of doing nothing. Is nasty talk occurring in that 10-second discontinuous interval? Plus, yes. Minus, no. Okay? So we can measure it. We define it. Can we manipulate nasty talk? Nope. We're going to manipulate variables, other variables that influence nasty talk. Nasty talk is the behavior. It's the other environmental variables that are going to influence nasty talk. Okay? Self-cutting. This is where an individual cuts themselves. Also called self-mutilation. Okay? Can we measure self-cutting?
Yes.
Yes. Yeah. We can do that. We can count the number of cuts on a person's arm when they come to see you in the office. We can take photographic evidence. Whoa, that's an interesting one. We take a photograph of somebody's forearm. Would that be event recording? Would that be interval recording? Or would that be a product?
It's a product.
It's a product. You do your intervention for this person who engages in self-cutting behavior. You take a photograph of their arm each week. If your intervention is working, what should we see on their arm each week in our photograph?
Less of the product.
Less of the product. Fewer cuts. Very cool. Okay? Examples of variables. Research design. This is a plan for the presentation or removal of the independent variable. This is a plan. A research design is a plan for the presentation or removal of the independent variable. So what is an independent variable? This is the variable that is presented or removed by the researcher, by the counselor, by the therapist, and is predicted to change the behavior. I just noticed a typo there. Okay, researcher. Okay? This is the variable that is presented or removed by the researcher, the therapist, the counselor, and is predicted to change the target behavior, the dependent variable. Okay? So I'm just going to go back. So let's look at variable once again, and we'll talk about nasty talk. Okay? We have a variable. It's a phenomenon. We can measure. We know that we can't manipulate that. We're going to use other events to cause a change in that behavior. Nasty talk is an example of our dependent variable. Our intervention would be the independent variable, whatever that intervention is. There's our dependent variable going forward again. The dependent variable is the measure of the target behavior. The dependent variable is the measure of the target behavior. This is the variable, the dependent variable is the variable that is predicted to change following manipulation of the independent variable. Okay? So, we're going to translate this in a different way. We're going back to our variables here. All right? Let's go to weight as a variable. We know we can measure it, right? Can we manipulate some environmental event that will alter a person's weight? Absolutely. And in the big picture, that thing that we're manipulating falls into two classes: exercise and nutrition. And those are environmental events that we manipulate. If we manipulate a person's nutrition, that's going to have an effect on this variable called weight. Okay? Likewise with exercise. If you exercise more, you manipulate that environmental variable, you present more exercise, that's going to have an effect on the dependent variable of weight in pounds. Okay? Target behavior. The target behavior is simply the behavior that's targeted for measurement or change. The target behavior. It's targeted for measurement or change. So, what is the purpose of a single subject research design? To discover laws of behavior. This is where all these principles that we're talking about in this class have been discovered through single subject research designs. Single subject research design is especially relevant in clinical or applied applications to determine if a treatment and intervention is working. They're especially valuable. Single subject designs can be used to rule out alternative explanations. In science, you want to rule out as many alternative explanations for the cause of a change in phenomena as possible. You want to rule out as many as possible. So then you come down with just this one explanation for the change in behavior or the change in the phenomenon. You rule all these others out through your experimental design. Two types of alternative explanations. Individual differences. I'm different from you, and maybe because I'm different from you, that explains the change in behavior. Individual differences. We've got to rule that out, that our change in behavior is not due to individual differences. Time coincidences. Did something happen at the same time or during the time in which the intervention was being implemented? If something happened at the same time as intervention, now we have confusion. It's called a confound. We've got to try to rule out events that occur at the same time as our manipulation of the independent variable, the treatment, the intervention. So we can conclude that our intervention was responsible for the change in behavior. We do that through research designs. Experiments have conditions. A condition is where we are doing something and only that something in that condition. Okay? So we already talked about an experiment. I gave you a little lead in here. An experiment is a type of research conducted to determine the cause of behavior. A condition or phase is a time period in an experiment during which only one thing is done. You're just doing one thing in that condition or phase. In single subject research designs, it's pretty straightforward. We have two types of conditions. One is called baseline. In the baseline condition, the only thing that you are doing is measuring behavior. So all you're doing is measuring behavior in baseline. Then the next condition is called treatment or intervention. In the treatment or intervention phase or condition, the only thing that you're doing is manipulating your independent variable. You're presenting an environmental event, you're removing an environmental event. You're presenting your treatment, or you're taking part of that treatment away during the treatment or intervention phase. And notice that baseline is followed by a capital A in parentheses. Baseline is always labeled A. The treatment condition is always labeled B. So we don't even need to use words, we can use letters and know precisely what's happening. A, baseline. B, treatment. If we have to add a new treatment because treatment B isn't working, what letter would we use? C. It's alphabetic. It's pretty simple. Okay? We're going to talk about 3 common single subject research designs. We're going to start out simple, and they're additive. If you master the concept of this comparison design, the next 2 are simple, straightforward, easy peasy. A comparison design is an A-B design. Baseline, intervention. That's all that it is. A comparison design is used to evaluate whether your treatment is working. That's all that this design is used for, to evaluate whether the treatment is working. And you do this by comparing the level of behavior in the A condition, baseline, to the level of behavior in the B condition, the treatment condition. So here's our baseline level, way up here. And then you compare the level of the behavior in baseline to the level in treatment. This one's lower. All things being equal, our treatment is working because the level of behavior is lower in the treatment condition relative to the baseline condition. If you want to find out if a treatment is working, you need to have a baseline. You need to measure the behavior before you begin your intervention. How many people have gone to their medical doc recently? Nobody? Nobody's gotten the flu, had the flu, you don't go to the doc because you're sick?
That's expensive.
Yeah. Okay, so I went to the doc because I was sick. They take baseline data every time you see the doc. So hearken back to the last time you saw a medical doctor. Did they take your blood pressure? Mm-hmm. They're taking baseline data on that private behavior called blood pressure level. Did they take your temperature? They should, if they're doing their job. They're taking baseline data on your temperature, another private behavior. So they have a record of your baseline data over every visit that you've had. And if your temperature is elevated, they can look in their medical chart and compare. Well, wow, he's been stable for this long and now we have this big temperature increase. And now they prescribe antibiotics, let's say, because you have an ear infection. The antibiotics is the B condition. They're presenting an environmental variable called drugs. What's going to happen to your measure of your temperature after you take the antibiotics?
Will decrease.
It will decrease. And if you have to go back to the doc, they measure your temperature again, and now we have another measurement of that same behavior in the B condition. So we can compare temperature in baseline to temperature in the B condition. This is what goes on in medical treatment all the time. Baseline intervention, baseline intervention. If the drugs don't work, then they prescribe a new set of drugs, right? When they prescribe a new set of drugs, what label would we give that phase or condition? C, exactly. And we do the same thing when we're analyzing or intervening for challenging behavior of a whole variety and type.
Dr. Lundervold.
Yeah.
How do we measure behavior that way though? There's no baseline of like no, like do we use that like we like ask people like how this one person acts or behaves like on a daily basis, or
It depends on what the target behavior is.
I guess we could go back to like self-harm. Like they don't usually self-harm, but like no one else knows that, so how do we know like if that's just their
If you have a patient who is engaging in self-harm, that's a secretive behavior, okay? But through the interaction between you and the counselor and the therapist, you're going to ask the question, like right away, that's what these two guys are learning how to do. How can I help? What brings you in here today? So now you're setting the stage for that person to talk to you, right? To disclose stuff, to tell you things. So they're going to tell you, hopefully, sooner rather than later, that yeah, I tend to cut myself when I'm angry, upset, frustrated, sad, blue, whatever. And then the natural question to ask, the right question to ask is, well, how many times do you do that when you start? Where do you cut yourself on your body? And if they say, I cut my forearms, the logical question would be, can I see that? Because as a professional, you need to know how serious this is and how raw those cuts are, how deep those cuts are, because you have to act in a particular way. So let's follow this up. How would we measure that? Okay, you'd have to get your client's permission. If I had, and everybody has a cell phone, right? Okay, so can I take a photograph of your forearm, just for my personal records? Because I want to know how serious this is, so I know what to do about it. And the two of us work together to decrease your cutting behavior, help you manage life better. So that person agrees to that, and then I would also work with them to do what's called self-recording, self-report, which we've already talked about, right? To then, on a data sheet that I would construct, have them count the number of times they've cut themselves. And it might be cutting every day, it might be cutting that occurs a couple times a week, but every episode of cutting might be 10 cuts or 3 cuts. So we're getting that self-report data that I need to know. Because just telling me, it's not quite as accurate as having that diary or that
So this part
record.
is the baseline?
This would be baseline. This would be baseline. And every patient that I see, I work with them to give me self-reported data on a data sheet. Because it's much different than them trying to remember way back last week. Remembering is faulty. That's why we want people to record right away, whatever that behavior is, because it's more likely to be accurate, more likely to be consistent.
So when we're talking to like a patient or something about an issue, we don't focus on like what happened, like the past. We focus on the now for baseline.
Correct.
Okay.
Because I'm going to digress ever so slightly. Can you change history?
No.
No. So we have to focus on what's going on right now, the current maintaining contingencies, which we'll talk about in the future.
Okay.
Okay? All right. With an A-B design, a comparison design, you cannot rule out alternative explanations. The only thing you can rule out is an individual difference, because we're just studying one individual at a time. But we cannot rule out coincidences, because maybe something happened in this person's life at the same time as the intervention. So we haven't ruled out those time coincidences. But they're exceptionally valuable for clinical work, for applied work, comparing baseline to intervention. Here's a picture. This one's a wee bit more complicated, but we've already covered it. These are real data from a real patient that I had 5 or 6, 7 years ago, something like that. Geriatric depression scale score. This is a self-report of how sad, blue, unhappy this person is. Depression. It's got a maximum score of 15. He's scoring like an 8 in baseline. Okay? Was able to get 2 observations. And all we're doing in baseline is measuring the behavior. He comes in, I talk to him, ask him a bunch of questions, and he fills out this questionnaire for me before he sees me. And then we went into the B phase. This is called cognitive restructuring, relaxation, and problem solving. And if you look at those data, compare baseline to intervention, the B phase, what would you conclude when you make this comparison?
Not working.
It ain't working, is it? It ain't working. So then we manipulated another independent variable, the C phase. This is called behavioral activation treatment. Now compare B to C. What would you say?
It works.
It works. Behavioral activation significantly reduced his depression. The cutoff score on the GDS is 5. Anybody who scores 5 above 5 on the GDS-15 is likely to suffer from major depression. And we were able to pull it down to, looks to be like a 2 as soon as we began behavioral activation treatment, and it went down further. Now, we're going to compare the C phase to the 6-month follow-up. What would you say?
It was maintained pretty well.
Pardon?
It was maintained pretty
It was
well.
maintained, yeah. And I ain't doing treatment for 6 months. He's out there doing what I taught him to do. He comes back, and all I do is assess. That follow-up is just like in baseline. The behavior is maintained 6 months after treatment. This is an extremely valuable tool, single subject research designed to evaluate whether your treatment is working. Yes?
What's the difference between B and C? Like, what was the 2 different treatments?
This is B, cognitive restructuring, teaching him to change the way he talks to himself about events, teaching him relaxation skills, and teaching him to a problem-solving routine. He worked as an accountant. The owner of the business, his supervisor, was demented, has Alzheimer's disease. If you know anything about that, people are confused, they don't think clearly, and they don't remember. So he'd show up at work, he's the accountant for this business, he'd show up at work, and his boss would then ask him a bunch of questions about had he done all this work that he was supposed to do. And he'd say, yeah, I did that. And the boss would say, I don't remember you doing that. So my patient began to worry about being fired because the boss couldn't remember what my patient had told him that he had done about all the accounting stuff. And then he also became sad, blue, and depressed. Behavioral activation treatment, we're going to talk about this very soon in the context of reinforcers and conditioned reinforcers. A reinforcer is any event that increases the likelihood that a behavior will occur. That's a reinforcer. And that reinforcer follows behavior. Okay? So in behavioral activation treatment, we built a schedule of valued and rewarding activities. So he engaged in that activity. It was rewarding. It was reinforcing for his performing that activity. When we come in contact with reinforcing events, our mood goes up. And in this case, his depression went down, his positive mood went up. A brief description of behavioral activation treatment. Yes?
Was the behavioral definition just like the DSM depression definition, or?
Yeah.
Okay.
That's what the GDS-15 measures.
Oh.
Let's talk about a more complex design, not a whole lot, but it also provides an opportunity to rule out alternative explanations. This is called a reversal design. This is where we alternate between baseline and intervention phases to determine the effect of those conditions on behavior. We're going to alternate between baseline and intervention conditions to determine the effect of those conditions on behavior. And we can replicate that design using more behaviors or more subjects or participants. Okay? So we start out with A, we go to B, and then we alternate back to A. And if our treatment, if our independent variable is working, we will only see a change in behavior when the treatment is present. The purpose is to demonstrate that the treatment is working and to rule out alternative explanations for a change or the cause of behavior. Just like before, with a reversal design, we rule out individual differences because we're studying one behavior at a time, or excuse me, one person at a time. This is an entire experiment conducted with one person. So we rule out individual differences. We rule out time coincidences by the reversal condition. We should only see a change in behavior when the treatment condition is present. If there are time coincidences and we take the treatment out, if the time coincidence is causing the change in behavior, then the behavior should remain high, just like it was when the treatment was present. If it goes back to baseline, then we've ruled out alternative explanation of time coincidences. This is a wee bit complicated, but it's got a lot of evidence of ruling out. Okay, this is a real case. This was done about 3, 4, maybe 5 years ago with a student working with me, doing what we used to do long ago, far away, behavioral tutoring. Okay, this was with a 60-plus-year-old woman with a traumatic brain injury that was 40-some years old. So she got a severe head injury when she was in her 20s. So this is a long-standing head injury that resulted in what's called perseverative behavior. Perseverative behavior is when you repeatedly engage in the behavior over and over and over again, even though the behavior is ineffective. You just keep doing it. Okay? She was in 2130, just like you, different book. She was in 2130, doing poorly, wanted tutoring. So we set up the tutoring program. And based on my own personal observation and the observation of the student doing the tutoring, when the student started to work with her doing the tutoring, the perseverative verbal behavior would occur. Okay? She'd start talking about stuff. But what she talked about was not relevant to what you need to study. Okay? You with me so far? Okay? So, here's our A condition, baseline, right? This is casual talk. Hi, how are you? How was your weekend? And whatever that person said, the tutor would give attention. That's the A. Casual talk, and then contingent attention. And if you look at the duration of perseverative talk, it was way high, almost for a total of 5 minutes. Each of these observations was 5 minutes in duration. And then we went to casual talk extinction, which we will talk about in the near future. This is where the tutor stopped providing the attention, would actually turn away and cease talking to her. Perseverative verbal behavior drops precipitously. Now we reverse conditions, we go back to baseline. Casual talk attention, and it goes way up. Okay? Now what we also wanted to determine was, is it something about this antecedent condition, casual talk versus technical talk? This class is kind of technical, wouldn't you say? A lot of technical information. So we manipulated then technical talk. The tutor started saying, give me the definition of that. What's the definition of this? Tell me what this example is. Technical talk, attention. And perseverative talk went way up. Because the tutor was now providing attention contingent on this perseverative, irrelevant talk. Okay? Even though she was trying to do the teaching. And we went to technical talk extinction, and it went way down. Back to technical talk extinction, it went back up. So what we have here is a series of A, B conditions that allow us to identify what event in the environment is regulating that perseverative talk. And it was attention. Had nothing to do with what we're talking about. It had everything to do with the consequence of the perseverative talk, attention. And then over here, we did it once more just for fun, to demonstrate that we can regulate this behavior. And then we went into a full-blown 50-minute tutoring session using technical talk and extinction. And then we replicated it again. We just kind of bound and determined to demonstrate that we could control, scientifically control, this perseverative verbal behavior through the environment. Let's look at a multiple baseline design. This is an experiment conducted with one behavior or one participant. It has baselines of differing lengths and interventions with differing starting points. Though we can replicate it with more behaviors and more participants. Think of the comparison design, A, B, right? Now, we're going to stack another A-B design. We're going to put another A-B design underneath our first one. So this is just a series of A-B designs stacked on top of each other, with the baseline being shorter in the first leg of the multiple baseline, a little bit longer in the second, a little bit longer in the third. So if we extend the baseline length, that means that the starting point of intervention will be different for each leg of the multiple baseline design. Purpose: to determine if your treatment is working and to rule out alternative explanations. We rule out individual differences, and we rule out time coincidences because we see systematic change in the behavior only occurring when we manipulate our treatment. And those other behaviors or those other people remain in baseline. Their behavior doesn't change until we present the treatment for those other people that are part of the multiple baseline. Here's an example. Okay, this is 2 legs out of 3. Okay, this is a student years ago who did a thesis out of my lab. Our dependent variable is percent relaxed behavior. Here's baseline 1 with participant 1, baseline 2 with participant 2. Baseline 1 has 3 observations, baseline 2 has 5 observations. And the data are being collected concurrently at the same time for each participant. Okay? We manipulate our independent variable, behavioral relaxation training, for participant 1. And if we compare baseline to BRT, what do we see? Huge improvement in percent relaxed. But the performance of participant 2, who's still in baseline, doesn't change. We manipulate the independent variable for participant 2 a little bit later. That's our step there. And this behavior only changes when we manipulate the independent variable. So what we've been able to do is rule out individual differences for this participant and this participant and rule out time coincidences because the behavior only changes when we manipulate the independent variable. If this change in behavior was due to time coincidences, it improves as soon as we start BRT, then this behavior should improve too for subject 2, but it doesn't. So we've ruled out time coincidence. Multiple baseline design. A little bit more complicated. Okay? Any questions? Yes.
So for this specific experiment, when
The last one?
yeah, this one, is there a certain margin that's like inappropriate? Like, because they were mostly 40, but then like participant 2 was down to what was that, like 20?
It's about 20,
Yeah.
Yeah.
So is there like a certain amount where you like have to consider them different, or is it just like because they're both mostly 40, it's fine?
What you're talking about is kind of two different things. One is, within this subject, is the variability in their performance. It
Mhm.
just bounces around, okay? This is just baseline. This is their performance of relaxed behavior without being taught how to do it. And we are directly observing and recording 10 behaviors using an interval observation system,
Okay.
okay? And this person, for whatever reason, this gets back to your individual differences, right?
Mhm.
This person, for whatever reason, is a little bit better than this person, okay? But look at what we were able to do. We went from 40% to about 95%, only because we taught them how. And the same thing occurred here, okay? Any other questions? Cody and Sawyer, it's up to you.
It's up to us.
It's up to you.
Okay, if you could, go ahead and get in groups of about 3.